last week, we still were talking about constrained optimization models, and we kind of added another twist to it. We said, okay, we can have our answer, we can have our solution, we can go another level deeper and kind of do some analysis and say, not only is this the solution, but what is the range of possible values where this will still be the solutions? And we looked at the range of optimality for that, you guys remember. So that range said, hey, even if that coefficient that is in this range, this is still the right mix. This is still the right solution up here. We also looked at, we know that some constraints are binding, which means, they're holding us back. They're solved with equality. That's how we know it's binding, because it's equal. That's the thing holding us back. And we said, well, what if we can get more of that value? Well, we could do that analysis. We could, add one and then rerun it. But we could also look at the thing called a shadow price. And the shadow price tells us, hey, for every movement change in this right-hand side, this is what happens to whatever you're trying to maximize or minimize. And that's a good thing. We can say, well, geez, look, we can get this much if we add an additional unit of this resource. But that shadow price isn't valid everywhere, right? It's only valid for a certain range of values. And we called that the range of feasibility. Do you guys recall this? And finally, we talked about something called reduced cost, and that was up above, and we sometimes have a reduced cost and sometimes we don't. But when we have a reduced cost, when it's not zero, what it represents is, hey, it's the amount by which we have to reduce the cost and hence increase the profit for this thing to become profitable, for us to be able to make this before it becomes non-zero. Also, if we say the hell with it and we force it to make one of those items, cost is going to go down by that value. Okay? So reduced cost typically, in a maximization model, is typically negative. So the homework that we gave last week, and I think we did the Mary's Pie one in class, so that one is kind of off the table, but the homework that we gave, is kind of taking what we did the week before and expanding it, or expanding the knowledge on that. So I think we did, 20, Mary's one is 27, 28, 26. So are there any of these specifically you want to do? If not, I'm just going to choose one and we'll analyze that. Because I want to do at least one before we get into new material this evening. So is there one that you guys would like to choose? Katie, go ahead.
Can you do 24?
Sure, let's look at 24. All right, so it says, Lawn Master produces 19-inch and 21-inch lawnmowers, which sells to membership warehouse and discount stores nationwide. Each lawnmower is powered by a Briggs & Stratton engine. The 19-inch model is a side bagger and requires 2/3 of an hour to assemble, test, and package. The 21-inch model is a rear bagger with a variable speed assembly and requires 1 hour to perform the same operations. Each week, Lawn Master can receive up to 200 Briggs & Stratton engine, has production facilities that manufacture up to 100 variable speed assemblies. There are 4 production lines, each working 8 hours a day, 5 days a week for assembly, testing, and packaging. Each 19-inch model nets Lawn Master a $50 profit, whereas each 21-inch model nets a $60 profit. Okay, so it sounds like, what we've been accustomed to is we have a production mix model. So I'm going to do it on here, so it'll be captured. So let's start. I'll do it on paper, and then we'll do it on Excel, because that's probably where we want to get to. But the decision variables here are what? What did you guys say for the decision variables? The decision variables are what? What would they be? We're deciding on 19-inch or 21-inch. And so I'm going to get fancy. I'm going to say X sub 19 are the 19-inch mowers. And we'll say X sub 21 are the 21-inch mowers. Yes, I think that's all I have going here. And it says we're going to maximize profit And that looks like each 19-inch model is $50. So 50 X19 plus 60 X21. Okay. And then as I went through there, and I didn't kind of figure out the details along with this, but I heard some things that were holding me back. So give me something in there that's holding me back. Go ahead, Sarah. Okay, so we can receive up to 200 Briggs & Stratton engines. So that sounds like something that's a upper bound constraint, so less than or equal to 200. And do they each take, I'm not sure, do they each take one? They each take one. Okay, so then that would be X19 plus X21 is less than or equal to 200, yes? Yes, okay. And then we also have, and it has production, 100 variable speed assemblies, is that right? So that's less than or equal to 100. What's the deal with that? Do they each take what? What do they take? Only the 21-inch? Okay, yeah. So it'd be X21 is less than or equal to 100 is all that comes out to be, right? Yes? And then there was a lot of math there, but I guess we're talking about production time. And it looks like the 19-inch model takes 40 minutes to assemble, test, and package. And the 21-inch model takes 1 hour. So we have 40 minutes versus 60 minutes. So how much time do we have? Well, it looks like it gave me a little math problem to do that. There are 4 production lines, so 4 production lines, each working 8 hours a day. So that's, what, 32 hours, 5 days a week, so times 5, so that's what, 160. So is it 160? Is that what you guys got? 160 hours? Okay, so, and Sarah's right. We either have to put it into minutes or leave it in hours and put everything in hours. So I think it's cleaner. You could do, okay, you could write this in a work. You could say this is 0.66667 X19 plus X21 is less than or equal to 160. But, you know, where possible, and that's all in hours at this point, right? But where possible, you know, it's good to avoid decimals, right? Fractions, we're better with whole numbers. So I would agree with Sarah that I'd rather write that in terms of minutes. And I would say, okay, 40x19 plus 60x21, and we have 160, so what is that, 9,600 minutes? So is less than or equal to 9,600 minutes. Okay. And we can't make negative lawnmowers. And I know we can't make fractional lawnmowers either, but these lawnmowers are just lawnmowers. They're not battleships or helicopters or anything. So if it comes out to half a lawnmower, fine. We'll just count that as work in progress or something like that, all right? So I don't want to use the integer constraint. We'll see tonight where we should use it, but in here I don't think we should use it, okay? Did I miss anything, or is that the model? That's the model? Okay, so let's take what we have on paper and let's transfer it to Excel so we can invoke solver. And it's fine if you guys go right to Excel. I kind of try to do it both ways because I think I told you on the in-class part of the exam, you are going to have to provide this, and on the take-home, you're going to have to solve it. So I kind of want to show you where those things come from. And I'm going to create this one from scratch, I guess, again. So I'll do it real quick because I'm sure you're already done with it. 19-inch and 21-inch. And I'm just going to 1-in-1 that, maximize, and we have what, 50 and 60. Let's get subject 2, and this is engines. And that's what, 1-in-1. We have variable speed assemblies, and that's 1-in-0. And we have time, and that's 40 and 60. And I'm going to put in my sum product here. C2, D2, C4, D4. And make that absolute. And copy that down. And this was less than or equal to, all these were, so I'll drag that down. Oops. Drag that down. And our right hand side were 200, 100, and 90, 600 respectively. So, you know, I want to format this a little nicer, but I think I have the gist. So if I change this, let's make sure everything is changing appropriately, and I believe it is. Okay. So let's solve this now. So I'm going to go to Data. I'm going to go to Solver. My thing I'm trying to optimize in this case is profit, which is an E4. I'm changing the variable cells, C2, D2, and I'm going to add all these constraints at once. So E6 through E8 has to be less than or equal to G6 through G8. Make unconstrained variables non-negative, simplex LP. I think it all looks good. So I click Solve. It says Solver found a solution. And I'm going to keep my sensitivity report along with that. Okay, so we have a solution, and that's probably part A, which is make 120 19-inch and 80 120 19-inch and 80 21-inch. But let's see, determine and interpret the range of feasibility for engines, variable speed assemblies, and production hours. All right, so before we do that, let's look at those three things and tell me what is binding. What of those three things are binding and which one has slack to it? What is binding?
Time.
Yeah, time is binding and the engines are binding. Okay, so it's asking us to come over here and interpret the range of feasibility, but as I do that, I'm going to interpret the shadow price as well. So let's see, for engines, we had 200 on hand. We used all 200, and the shadow price is $30, meaning for every additional engine we acquire, we can make more and our profit will go up by $30. If we lose an engine, if we go to 199, our profit goes down by $30 because we're losing an engine. But that doesn't last forever, okay? Basically what it's saying is that $30 increase is only good for up to an additional 40 engines. That's what the range of feasibility is saying. So I can't get 50 extra engines and say each one's going to get me 30 bucks. What happens is once I hit that 40, probably something else becomes binding. Something else is holding me back, right? So the shadow price is telling me how much more profit I can get, but only in this range of feasibility. So if the allowable decrease is 10, the allowable increase is 40, we're talking 190 to 240 is the range of feasibility for engines. Now, if I could pay $30 for an engine, would you buy that engine? That's the question. And I want you to think about when someone figured out we make $50 profit for 19-inch and $60 profit for 21-inch, how did they figure out that profit coefficient? What did they do? What did they do when they figured that out? How did they arrive at 50 and 60? We don't have the math for that, but just how would they arrive at the math for 50 and 60? What would they do?
They take the total price of what it costs to produce it and how much they sell it for and track what's left as profit. Sure.
So we're going to sell it for $250, right? That's great. We get $250 revenue, but we have to back out all the costs to produce that, right? The raw material, the engines, the time, all those things. So whatever the cost of that original engine was, it's already factored in to that $50 and $60. Maybe it was 10 bucks. I don't know how much. Let's say it's $30. That was already factored into that 50 and 60 coefficient. So this $30 doesn't represent the price I should be willing to pay. It represents the premium above what I normally pay that I should be willing to pay. So if I can get if I can get variable speed, or if I can get engines for whatever I get them for originally, it really is $30 more every time, right? Every engine is worth 30, you know what I'm saying? So if I can get them for the price I normally obtain them at, that is a true $30 profit. That is a true $30 I wouldn't have had, because that is already baked into that. It's called an included cost. Does that make sense? And time would be very similar, right? Time would be very similar. So every extra minute is a half a dollar. So $30 an hour for production time. So if we normally pay people, I don't know, $20 an hour, you know, if we pay them time and a half, we're good, right? We'd be okay. Does that make sense? We'd still be making profit. Now, why is variable speed assemblies, if you look at the allowable decrease, it's 20, and the allowable increase is 1e plus 30. That means infinity. Why is that structured that way? Explain that to me. Why one is 20 and one is infinity, basically? Because that is telling us where that shadow price is valid. And the shadow price is 0. So what is that saying? Explain that to me. Okay. Only what? That helps us, but if we look at this, okay, the shadow price is 0. So what that's saying is, if we get an additional variable speed assembly, it's not going to change our profit. And also, if we lose one, it's not going to change our profit. Why is that then? But why does it not matter if we get another variable speed assembly or we don't get another variable speed assembly? Yeah, we had 100 of these things and we only used 80. So if we lose one, all right, we can still make the same amount. Yeah, I know we're out that inventory, right? Someone stole one of our assemblies and we're mad and connect it. But it doesn't affect this production mix, yeah? Unless we lose more than 20, because we're only using, of those 100, we're only using 80. But once we lose more than 20, hey, that is going to change things. And why this is infinity? Because it says, well, you're only using 80 of the 100, so I don't care if someone gives you, if you have access to thousands and thousands of more variable speed assemblies, that's not what's holding you back. It's not going to help you, right? Your profit's not going to change. So typically what you'll see here, and it's not always the case, but generally what you'll see, the things that are binding, the things that are holding me back, will have a shadow price, and the things that aren't, the things that have flex or slack, will have a shadow price of 0. Okay? So this shadow price tells you what happens when you get additional or lose additional units. But this allowable increase, allowable decrease always goes along with it. It tells you, hey, where is that shadow price valid? Where does that shadow price have interaction? So that's good. That was a good analysis of the bottom hand, of the right hand side. We'll do C, but let's look at this up here first. Okay? Let's look at 19-inch and 21-inch. Let's look at up here. So interpret the range of optimality for the 19-inch motors. What is that saying? It says allowable increase 10, allowable decrease 10. What is that saying? What does that mean? So right now we're projecting $50 profit for 19-inch motors. We're projecting $60 profit for 21-inch motors. If I say, due to market conditions, I think I'm only going to make $45 profit for 19-inch motors, what does that mean? Does that change my solution?
No.
Kevin? It doesn't. Why?
Because it's $50 for US.
Right. The range of optimality for this guy, it starts at 50. That's where it's at now. But it says, hey, the allowable decrease is 10. So 40. That's 40. The allowable increase is 10. That's 60. So that's the range of optimality. Anywhere in that range, it doesn't matter if we make 40 to 60. It's saying the right solution is to make, 120 and 80, right? Well, that was the solution. That's the right solution. Now what does change, Devin? If our profit goes down to 45 bucks, it's still right to make 120 and 80, but what does change? That's the profit changes, obviously, because I'm not making 50 bucks, I'm making 45 bucks. Even if it goes up to 55, 120 and 80 is still the right mix, right? So that's what that's telling us. So it not only tells us it's a solution, 120 and 80 is the solution, but it tells us, here's the range where that solution is still the right mix to make. Because remember, we're projecting this. We don't know this. So now I tell my boss, I tell her, if our profit margin goes up 20% or down 20%, 10 and 20% of 50 is 10. We're still okay. This is still the right mix. So I have more confidence in the solution when I present it. It's not like a narrow solution. Does that make sense? I say, I know I baked in some assumptions here, but this is a solution in that mix. So that gives it more credibility. I'm going to kind of play around with this, and so I'm going to make 19-inch mowers wicked profitable. So for whatever reason, I'm going to make them much more profitable. And I'm going to resolve this. And I'm going to keep the solver solution, and I'm going to keep the sensitivity report. And it's told me now, because it's so profitable, obviously it's trying to optimize profit. It's moving all production to 19-inch, right? That's what you would do too. If it's that profitable, hell, make hay while you can. So if we look at the sensitivity report for the new solution, it is telling us what? What do we have that we didn't have before up top there? We have a reduced cost. And the only one that has it is the 21-inch mower, because we're not making any 21-inch mowers. And it's telling us reduced cost is negative 140. What does that mean? Interpret that for me. What is that saying? What does that mean? Yeah, if we say the heck with it, we want to make some 21-inch mowers because we want to be in that business. You can, but the profit that we're figuring out right now is going to go down 120 bucks because you're moving resources from the more profitable product to the less profitable. So you can do that, but there's a cost to that, and the cost is $120 per unit, right? That's fine. Alternatively, or $140 per unit. Alternatively, it says what? Alternatively, it says, what else? Yes, Eric?
You cut the cost of 21-inch by 140.
Yeah, if somehow it's the negative increase necessary to make a positive and final solution is the way it reads, or the other way you say, well, if this goes up for this to finally become positive, I have to go up, well, right now the objective coefficient is 60. It has to go over 60, minus the negative 140. It has to go over $200. And then I would start making them. So, you might say, well, why aren't I making them? Well, because, it's not competitive for our resources with that other product. And that's why some people discontinue lines of products, right? They say, maybe the demand's not there, but maybe we only have so many hours, we only have so many resources. We say, hey, whatever. This is where we're going to market. Spend our time making money because it's more profitable, and this is why we're sunsetting this line of profit. So I think that let me go back to what was it, 50, right? And I'll resolve it. Just put it back where it was. And let's go to look at C. C says, if an emergency develops so that the amount of production time fell just below the lower limit determined in Part B, what would be the new optimal production schedule? So I'm guessing they're saying 1,600 was the allowable decrease for time. So if we went to I'm looking at the wrong one. This is this one. Sorry. 1,600. Wait, that's. If I went down to just below 7,999, I click solve, resolve. Okay. We moved all production now, all production to 19 inch. So if you think about it, you know, you say that's a pretty dramatic change. Well, yeah, because remember, you know, we have that feasible region. These are the feasible points. And we said if there's an optimal solution, then it might, they all don't look like this. I draw them all the same, but they look like this. We're saying, you know, we changed the line, right? So we changed one of these constraints. We moved it in, and now the last point of touch might be here instead of here. So it can be pretty pretty dramatic change, you know, in the production mix with just not a big change there. So that's another reason you want to look at that sensitivity report, because you might say, you know what, I'm not real happy with this mix for other reasons, things I couldn't bake into this model. You know, marketing's not real happy with this mix. You know, it looks like we're real close to maybe another optimal solution. You know, let's change it and see if we can hit that other optimal solution. And what's the difference between what we have right now and what that other optimal solution would be? Yeah. So I'm trying to look for the best, but not always the best, right? Because there's things I can't bake into the solution, right? There's just certain things I can't do. Does that make sense? Yeah? Okay. Any other questions on the homework? It's cooler here, isn't it?
I had trouble doing interpreting the shadow price.
Which one? This one?
In 28.
28. Let's look. Instead of solving 28 from the beginning, do you mind if I bring up the solution?
Yeah,
Okay.
I just didn't see the solution.
Let's look at 28. Hopefully I have it on here.
Imagine.
Okay. Okay, so if I recall with this one, we were making this book dated once again. We're making computers with floppy disk, if you remember those floppy hard drives. Kind of fun. Hard drives, cases, labors, and we have a contract. And I think the contract was that we had to produce 300 KCUs because we have a contract. We have, you know, we told someone we're going to produce those. So let's look at the sensitivity report. And was there a specific, Jill, right, Jill?
Yeah. I didn't understand how to interpret the shadow price.
For the contract?
Yeah, and for the production hours.
Okay.
I don't know,
Well, let's look at, we have 5 constraints, right? And the first 3 aren't binding. You know, we have 1,800 floppy, we only use 1,200. We have 700 hard drives, we only use 600. We have 1,000 cases, we only use 900. So that's, you know, that's why they're 0, and that makes sense. They're not binding. Labor is 480, and we use 480. So that means, you know, we're binding there. That's something holding us back. And it has a shadow price. I'm guessing that's in minutes. I'm not sure. Probably in minutes, yes. Or maybe it's hours. Is it in hours? It could be. Yeah, I don't know. Is it in hours? Okay. So it's saying $416.67. So every additional hour would yield us additional profit of $416.67. And if we lost an hour, we would lose $416.67. So, and that's only valid, Jill, in this range of feasibility. Allowable increase is 60, so 480 plus 60 is 540. The allowable decrease is 360, so 120. So anywhere from 120 to 540, any change in that range is going to be 416 to the good or 416 to the bad. Now, I want to look at this one because it's kind of odd. You see a negative shadow price, right? Well, interpret that for me. And remember, that's the contract. We have a contract with someone that said, we have to, they ordered 300 of these KCUs, I believe, and we said, yeah, we'll produce 300 KCUs for you. So we did. But it says negative 66.67. Interpret that for me. Okay, so if we say, if we increase that contract to 301, our profit's going to go down $66, right? So an increase up here is going to take my objective function value down. So if they call and tell me, hey, we only need, I don't know, 250 of those, well, that means opposite. I'm decreasing that amount, right? 200 from 300 to 250. My profit's going to go up $66.67 for every unit. So, quite a bit. The reason for that is what? Why is that? Why is that? So it's negative. Why? But why? Why is it negative? That's what it is. But why?
If you hadn't had the 300 constraint, it wouldn't be optimal.
Right, it wouldn't be. Like it's saying it's more profitable to make KCUs, right? So it's saying that constraint, by adding that constraint that I have to make, KCUs, is taking production resources away from the more profitable KCP, which is fine in the managerial world. Why? Why is that fine? Why when I read this would I be willing to accept that? Because why? I'm like, okay, fine. I'm guaranteed to sell those damn things, right? So I'm saying, yeah, all right, well, I'm willing to accept that. I know that I move resources from a more profitable product to a less profitable product, but I know I have that's a done deal. These I'm not sure. I don't know the market, right? So if I could relax that constraint, sure, it's going to make more KCUs for sure. And let's see. So I'm going to relax it to, let's say it is, what was this here for? $67. So let's go down to 290. So now I only need to make 290. If I solve it, well, the allowable decrease is 150. It's going to go up by a negative of that, which is, it's going to go up like $667. So let's see, we're at 180,000. So if I do data, solve. Oops, it went to the wrong. What did that? It went up $666.67 roughly. Okay, so yeah, that's the case. And remember when we said adding constraints takes away options, right? Always takes away options. But in real life, we have constraints we have to deal with, and we have a contract, which is great. So we said we have to make this many. There's all kind of constraints, like you think about it, like I said, you'll start thinking of decisions you have to make in this way. There are things that you can decide. There's an optimal goal you have, but there's things you have to adhere to, right? Like you want to have the most fun you want, but you want to stay married. There's things you want to do, right? So this is you can think about a lot of things in the business world that way. Managers have finite resources, and they make the best decisions with those finite resources. Yes, and inside a scope. And this can't model everything, right? This can't model everything. That's why when we look at it, we need to say, not only is this a solution and follow it blindly, but let's look at other possibilities and what happens if this happens. Because it's more of art and science than just science. Okay, any other questions? Does that help? Yes, okay. All right, so if there's no other questions, we're going to move on to chapter 3. And I thought to myself, instead of looking at the notes, I thought, and going through the slides, I thought we would just kind of work on a problem together. I think that might be a better way to teach this. So I kind of made up a very, very generic problem, and I'll pass these out. There's things we'll use later, so pass these. All right, so I made basically a generic problem. So it's a production mix problem. Let's start with like a basic problem you can understand. So we're making A, B's, and C's, right? That's pretty simple. And we're maximizing profit, and the profit coefficients are 10, 20, and 23. I don't know, we have 3 limiting resources. We have resource 1, resource 2, resource 3. And we have 15,000, 10,000, 12,000 respectively. A, B, C is greater than 0. So we've seen the form of this. So if you turn the blank, so this, you want this side up. And if we go into chapter 3, if you want to look, click on, it says summation variable generic example. So it's like the 4th thing down. Oh, you guys can't see what I'm doing. It's under chapter 3 on Blackboard. It's the 4th one down. It says summation variable generic example. So instead of resolving this, okay, I just kind of, instead of you doing all that work, I took that thing on your piece of paper, I put it into Excel, and I solved the damn thing. And it says product A makes 0, product B makes 1,077, product C makes 385. And it looks like resource 2 is binding, and resource 3 is binding, and resource 1 we have slack. And we make profit of $30,385. Okay. But oftentimes, we go into situations like this, and we have like mixed constraints, okay? Like maybe marketing has told us, I think I have that down below, and a lot of times these constraints come from like people in the marketing area that understand like our market, and you know, we don't want to produce all of product 1 because we want to have product 2 because, you know, there might be goodwill loss, like, hey, you say you specialize in this, but you have only these products, and I need these sometimes too. So you don't always want to just produce the most profitable thing. So sometimes a marketing department might come in and say, product A, B, and C, we want to make sure that whatever we produce at least 10% of each product of A, B, and C, right? So if we produce 2,000 units, we better produce at least 200 A's, 200 B's, and 200 C's. And if we produce 5,000 units, we better produce at least 500 A's, 500 B's, and 500 C's. Does that make sense? So that marketing has told us. Let's take that. So we need to do that. So what? Well, before I solve this, it looks like I'm making 1,462, something like that, 1,462 products. But before I solve this, I don't know how many products I'm going to end up with, do I? I don't know what, before I solve this, if I'm going to make 1,462 products total, or if I'm going to make 500 products total, or I'm going to make 1,000, because all this has to mix its way out and come up with a solution, right? Like, we don't know if we're going to make, how much of this stuff we're going to make. So we need to predicate a constraint on some total we don't know. You know what I'm saying? We have to predicate a constraint. If I knew I was going to make 2,000 items, easy. A has to be greater than 200, B has to be greater than 200, C has to be greater than 200. But I don't know going into this how many items I'm going to make. I don't know if I'm going to make 500, 1,000, or 2,000. So it's hard to write that constraint. Well, the solution to that is we have to create something different called a summation variable. Okay, and I want to do it on paper first, and then we'll move it over into Excel world. Okay, so let's go to our model that I wrote on paper, and this looks all well and good, but I know, okay, I know that marketing has said every product has to have at least 10%. And I don't know what of the total, but I don't know what the total production run is at this point. So what I'm going to do, okay, and I want you to follow me here, is I'm going to create a brand new variable called, well, let's do option 1 first. So I'm going to do this a couple different ways. Option 1 is the harder way. So let's do that first. What is the total? I need to make sure that A, let's do one at a time. I want to make sure that A is greater than 10% of the total. So what's the total production? How would I get total production mathematically? I want to make sure that the number of A's I produce is greater than 10% of the total production. So what is total production? I don't know, but how could I get it mathematically from A, B, and C?
A plus B plus C.
Very good. So it would look like this. One way I could write that constraint is A is greater than 10% times A plus B plus C, right? Because A plus B plus C, you're telling me, is the total, and you're right. But it doesn't work well like that because, you know, I kind of remember, I always kind of keep things in their lines, and like, some products work better that way. So I always have over here on this right-hand side, I always have like a coefficient, like just a number, right? It's always just a number. And this has variables on the right-hand side and a variable on the left-hand side, but algebra tells me I can move things around. So I'm going to go from this step to this step, and I'm going to say A is greater than, well, let's apply that or distribute it. 10% A plus 10% B plus 10% C, right? I'm just distributing that 10%. And I want to get a coefficient on the right-hand side. So I'm going to subtract this from this side. And if I subtract that from this side, I also have to do what? Because it's an equation. I have to subtract it from this side. Okay, so this is just algebra, right? So what does that end up? That ends up in 0.9a, because there's one a up here and I'm subtracting 0.1, minus 0.10b minus 0.10c is greater than or equal to 0. So what we just mathematically modeled there is we're trying to say that at least 10% of production has to be in A, whatever A is. And mathematically, that will do it. Okay? That will do it. That will model that. The problem with that, and it'll work, and you can do it that way if you want, but is that intuitive? Like, does that, when you read that, does that scream to you 10% should be in A? I don't think it does, right? Because it went from here to here, and you're like, oh, what the heck? There's negative coefficients there. It's not good. So what we do then, okay? So option 1 is an option. It's still an option you can use. Okay?
Is that not
Yeah.
A negative?
Which one? I'm sorry. This one?
Is that negative 9A?
Just 0.9a, and the reason for that is Maria, we have 1a up here, and we're subtracting 0.10a from it, so 1a minus 0.1a is 0.9a. These are negative because there's no b and c over here, but this is positive. Does that make sense? All right, so we're saying option 1, not the greatest option. But what we can do, in our piece of paper, option 2 is we create a variable, another decision variable. So we have A, B, and C. Let's create another decision variable, and we'll call it tot for total. Okay. So this is still a decision variable. And now, what I want to do to like create that decision variable is I need to set a constraint that forces total to be the sum of A plus B plus C. So a constraint that I would add would look like this. A plus B plus C is equal to total. Or another way to write that is A plus B minus plus C minus tot is equal to 0. This is called a definition constraint because it defines a summation variable. This constraint itself creates a summation variable, and that summation variable is total. Okay, it's a decision variable, but it's something that I've created, right? It's a variable now I can use. So once I have total, tell me how I write a constraint that says A has to be greater than 10% of the total. How would I write that constraint now? Instead of that 0.9 minus 0.10b minus 0.10c is greater than or equal to 0, how would I write it now? Now that I have this new variable that I created with this definition constraint called tot, what would I have to do? How would that constraint look now? Yep. So A is greater than or equal to 10% of tot. But once again, I want to get this over. So minus 10% of tot is equal to 0. And remember, I want to do the same thing with B and C. So what would that look like? B minus 10% of tot is greater than or equal to 0, and C minus 10% of tot is greater than or equal to 0. Okay, that is called, this total is called a summation variable, and the constraint that creates it is called the definition constraint. So I'm going to do it. Let's stop here, okay, and let's go to Excel, and let's make both of these things happen, because I don't care which one you use, right? Classical kind of statisticians or management scientists say this is the only right way to do it. This is option 2. There's actually option 3, which I'll show you as well. But let's do option 1 first, okay? So I'm gonna, and you guys can do this with me. And we're just gonna do the A constraint. So you guys find this on Blackboard, this file that I have. So let's do 10% or more in A. And if you recall, option 1, if we focus on those coefficients, it was 0.9. That's what we want to focus on, right? 0.9. Negative 0.1, negative 0.1, and we're saying greater than or equal to, greater than or equal to 0. Okay. So remember, 0.9, negative 0.1, negative 0.1, greater than or equal to 0. Oh, how far are you going to let me go, you guys? I once taught for an entire morning, like 9:30, 2 stats class, 9:30 to 12:15. basically 3 hours of teaching with toilet paper on my neck because I caught myself shaving that morning, never took it off, and was never told. You know, like, they just say,
That's a very fine line, like, do I say something or
yeah,
just
you
let it
say
go?
something. Yes.
When I put in negative 0.1, it says my formula will be different.
When you put in negative 0.1,
Yeah, it says found an error in the formula.
Just make it bigger. Okay.
That's fine.
you don't think.
Oh, wait.
I just put a 0. But this one pre-filled.
But I have no idea why to do that.
Oh, do you have like, where did you get that? You got it in America? The Americans don't use commas as
I don't
decimal
know why.
places.
Yeah, that was just like a preset on my Mac that I never figured out.
Oh, that's what it is, yeah.
Yeah, sorry.
Okay. Okay, so we entered this in. Now we have to tell it about that constraint. So I'm going to say data, solver, add, and I'm going to say, in this case, F9 is greater than or equal to H9, which is 0. And if I resolve, I don't know why it was GRG, but change it to simplex. Click solve, finds a solution, and you'll see we're probably making 1,460 roughly. So we're making 1,462, and it did force 10%, roughly 10% of production into, there's probably a decimal place there. Yeah, there is, 0.2, there's probably a decimal place. Yeah, so it did force 10% of production there. Did yours not work, you're saying? No one's worked?
I got 0 for product today.
Did you tell it about the constraint?
Yeah, I added it.
It's greater than or equal to? Did you change it to greater than or equal to?
Okay, let me change that.
I got negative 3, negative 14.
This?
Yeah, but it's 3. It said 3E.
Good.
Is that all right if it rounded off to 3? Okay.
This is, what is this?
Okay.
This value that I have highlighted, what is that? It's 0. It's negative 2.84 times 10 to the negative 14th, which means it's 0.13 zeros, 284, which is virtually 0. So yours might be negative 3.16 e to negative, but it's still 0. The way this solver works is it goes through multiple iterations and it says, hey, I'm close enough, I'm stopping. Yours might have stopped, you know, just because of the nuance of the machine it's running on and the chip it's processing with. It might have stopped a little bit shorter than mine or a little bit longer than mine, but it's still the same. You probably have the same answer, yes? Or the answer, this answer. Yes? All right. So that's one way to do it, Okay, that's one way to do it. Let's do it the second way. So I'm gonna zap out that constraint. I just right-clicked on it and zapped it out. And I'm gonna get rid of it in Solver. The Solver's complaining to me, it doesn't know what I'm talking about, so I'm gonna delete that out of there as well. All right, so I'm going to go to column F, and I'm going to right-click, and I'm going to say Insert. And I'm going to create a value here. This is us going. We're going to create a fourth decision variable, and we're calling it total. And I'm just going to put 0 in it for now. And I'm going to put 0 here, 0 here, 0 here, and 0 here. And it truthfully is a decision variable. So I need to adjust a lot of things because it's another decision variable. So the first thing I need to adjust is all my formulas go from C to E. And I want them to go the whole way to F. So, oops. Up there. C2, F2, C, oh, it's red, that's why. Can't see it. You guys struggling with that too? Or if I go up there, I can see it better. So I want to go from C2, F2 to C4, F4. And you see that little green triangle in there? In the upper corner? You guys have a green triangle in the upper corner? Like in this one and this one. And then you click on it. It's kind of warning you that like you may be missing something. Like if you ever see that, you might be right, but it's kind of warning you. So I'm going to copy that one I just created and fix it so that it's referencing. Because I made that red, I can't see the red text, which is kind of bad, but you see it up here. I went C2, F2 to C4, F4. All right. Now, if you recall, option 2, we needed to define this guy. So we need to define that total, that one up above. And it looks like we need to say 1A plus 1B plus 1C minus 1 total equals 0. That's how we define it. So let's show that on Excel. So I'm going to say definition. I'm going to say 1A, 1B, 1C minus 1 total. Okay, and I need to, if I put an equal sign in this, it thinks I'll put it in a formula sometimes, but I'm not. So if it thinks you put in a formula, put in a little, put in a single quote and then put in the equal sign, and it'll take it as a symbol instead of a formula. So it seems like it already recognized it, but if it doesn't, put a single quote and then the equal sign. You know what I'm saying? If you put an equal sign alone, sometimes it says, hey, you're entering a formula, and no, I'm not, I'm just entering an equal sign. And we want to say equal 0. Okay, so all I'm doing is creating this summation variable now. The way I create this summation variable is I add a new decision variable called total, and then I force total to be the sum of these three. using a constraint. So let's go to data, solver. I'm going to maximize E4. My changing variable cells now are C2 through F2. That summation variable needs to be a decision variable. It needs to be able to change. Okay, so it needs to be, I need to expand that range. I need to include it up top. And now I need to tell it about this constraint that creates it. I'm going to say add G9 has to equal, so I'm using the drop down to go to equal I9. And I click add. So I expanded the decision variables from C2 to D2, from C2 to F2, and I told it about this new constraint. So now if I solve it, all it did was force F2 to be the sum of these three. That's all that did. But now I have a cell I can use. You know what I'm saying? Now I have a cell I can use. So now I can put in this one. I can put in A minus 10% total is greater than 0. And I can put B minus 10% total is greater than 0. And I can put C minus 10% total is greater than 0. And that's what I intend to do. So I'm going to say A 10%. And I'm going to say 1 minus 0.1 is greater than or equal to 0. I'm going to say B 10%, 1 minus 0.1. I got to copy that down, greater than or equal to 0. And C 10%, 1 minus 0.1 is greater than or equal to 0. So all I did in row 9 was created this new variable. It's called a summation variable. And now in 10, 11, and 12, I'm using that thing. So now I need to tell solver about it. So I'm going to go to data, solver. I'm going to enter all three of these at once. I'm going to say add G10 through G12 has to be greater than or equal to I10 through I12. I solve, find the solution, and you see once again it forces $146 units in product A. Everything is more than 20%. Now, what's nice about this is if I'd have done it option 1, I kind of had to redo the algebra if I wanted to say change this to, let's say each has to account for 25%. I would have had to redo that algebra for that and say, all right, this means it's negative, you know. But here, all I have to do is change this one to negative 0.25, this one to negative 0.25, this one to negative 0.25. And now I resolve, and now every product has at least 25% in it. Did it work?
Question for
Sure.
the optimal solution. I'm only getting 1515 instead of 26,000.
What? Right here?
Yes.
What's your mix look like?
C2 to F2, C4 to F4.
No, what's your numbers here?
146, 931, 385.
Okay, so, yeah, that's not right for some reason. We'll look at it. Oh, okay. Do you still have you're still using 10%, Lori?
Oh, yeah.
Oh, okay. I just changed it to show you what you changed. So you're right, I think.
Well, no, either way, I'm only getting 15, and it was like 26, or is that what it was, the first one? At 10%?
I don't know. Let me solve it. Not getting, so you're.
I didn't have the total.
Oh, I didn't, negative. Are these the numbers you're getting, Lori? Yes? All right, I'll take a look at it, Frank. Go ahead, Sarah.
Oh, this satisfies the 10% part of the question. How are you taking care of the 55? Okay, we don't got that.
That's a good, you're gonna take care of that during break. So, yeah, we didn't do that yet. So you, being what we did right now, for break, I would like you, as well, no single product should account for more than 55% of total production. And right now, it looks like 9B is accounting for more than 55% of total production. So I want you, and it shouldn't be, but you have to add some kind of constraint so that that is not the case. So we did the 10% part, as Sarah said, but we didn't do the 55% part. So you guys saw that point there. Okay, so that's a good breaking point. Come back at around 10 till 8. And if you have questions, I'll come around and take a look. So before break, we said we have this working, but we also want to account for the second part, that nothing should account for more than 55% of total production. And if you look at it right now, 931 is, I don't know, probably 60-some% of production. So now that we have this definition, this summation variable created, we can utilize it. So I'm going to do less than 55%, B less than 55%, and C less than 55%. And it's going to look very similar, where it's going to be 1, 1, and 1. So it's going to be A, B, and C. I'm just going to make that font bigger. And because it's 55%, it's going to be negative 0.55 here. I'm going to have to copy down my formula, drag down my formula. And this is less than or equal to 0, 0, 0. I'm going to freeze those top cans. You don't have to make the format the same. Okay, so we can see just by looking here that B violates it by what, 127 units, right? 127 is not less than 0. So let's tell Solver about it, so Solver can fix it for us. So I'm going to go to Data, Solver, Add, and I'm going to say G12 through G14 in my case. Has to be less than or equal to I12 through I. Wait, what did I do? No. add that again, add, it's 13 through 15, no, I'm sorry, it's G 13 through 15 is less than or equal to I 13 through 15. Click add, click solve, solver finds a solution, and my solution now accounts for all those things. So it's everything is at least 10% and nothing is more than 55%. You notice anytime I added constraints and it came up with a new solution, what always happened to my profit? It always went down because think about constraints. They're taking away options for you and taking away more profitable options for you. But if that's how we want to make our decisions, if we want to make our decisions such that, hey, we want to have at least 10% of every product and no product should come from more than 55, that is the optimal solution, right? If we wanted to find out what's holding us back in this situation, this kind of goes back to what we did last week. What would we do next? When we resolved it, what would we keep this time? When I solve it this time, I would keep the sensitivity report. And we can see things that are binding. So resources 2, resources 3, whatever that is, binding. G14 is binding, so that's the B is less than 55% because B must be profitable. It wants us to make Bs. All right. So save this if you like. I'm gonna. I'll save it. And close it out. And I'll show you option 3. So let's bring back that summation variable generic example without all the stuff we've done to it. So bring it back to the basics. So just go to Blackboard and bring back this copy. You're probably going to ask me why I didn't show you this way first, and the reason I didn't is because this third way is not really a classic way to do it, and it does have some limitations, okay? But it'll work. So if we don't know how many we produce, let's just grab a cell, we'll call it H2, okay? And let's put in H2 a formula that says equal sum C2 through E2. And I've created the total, right? And now, I can go to my solver, I can click Data, I can click Solver, and I can add a constraint. So let's just add that A has to be greater than 10%. Okay, and this is kind of just like hard coding it into the constraints. I'm going to say A, which is C2, has to be greater than or equal to H2 times, and times as you guys know, the asterisk, 10%. Click that. So I'm putting inside the constraints, I'm saying C2, which is my product A, has to be greater than or equal to H2, which is my total that I created with the sum function, times 10%. I click solve, and it gives me 1 now using that same method, put in that product B has to be less than 55%. You guys do it in the group. So if I want to say product B is greater than 55% of total, I can say solver, I can say add, and I can say product B, which is D2, is greater than or equal to H2, which is my total, times 55%, 0.55. Add, cancel, solve. Oh, thank you. Change, right, less than.
You have to solve it using that nonlinear use syntax.
That's one of the issues. Let's see. Sometimes it also not work for that one. But sometimes it does. The simplex LP, you're going to see. There are times when we can't use that, but yeah, it looks like it. Okay, so 3 options to get there. But this is often the case where we're talking about, anytime we're talking about percentages of a whole, we're going to have to employ one of these options. Summation variable, just the algebraic method, or use the sum function. Now, what I'd like you, we're going to do 2 things today, 3 things, but we're only going to do 2 based on how tired I am. So the second thing I want to do is I want you guys to look at the sheet I gave you. And I want you to look at problem 1, okay? So one thing we're going to add in is we have constrained optimization models. We're understanding constrained optimization models. But in chapter 3, we're going to also cover integer and binary examples. Now, integer is when we're saying that some of those decision variables have to be integers. They can't be 1.63, they have to be 1 or 2. They have to be a solid number. Binary, which are more difficult, we'll cover next week. Binary examples are the values have to be 0 or 1, like on or off. Okay, so there are cases where that works good. Like what it works good for is like project selection models. Like, hey, you either do the project or you don't do the project, right? You either start these 5 runners or don't start. You know what I'm saying? It's either 1 or 0. Okay, so it works very well for that. Where integer constraints are necessary, and we try to avoid them, because when we use them, we won't get the sensitivity report. We can't use it because it's not a smooth region like this. If it's integers, it's kind of disjointed. So we can't use, there's no sensitivity report that comes. But if we look at the one that I handed you, I think I have a couple copies for myself somewhere. If you look at the one that I handed you, I want you to take a few minutes. And I want you to try to set this up because it is a staffing model for MECO Consulting, and it involves the 2 things. It involves summation variables, which we just learned, and it has to be integer because we can't hire 1.6 software engineers. We either hire 12 or we hire 13. We can't hire 12.25. Okay? So the decision variables are integer. So all I want you to do is, let's take a few minutes to try to jot it down. What the decision variables are, what the objective function is, what the constraints would be. And then we'll move it to Excel and we'll solve. Okay, so it's up to me. Okay. All right, so Miko Consulting is expanding its IT consulting business to the Blair County area. The company wishes to be able to serve at least 75 personal and 25 corporate accounts per week. Miko Consulting plans to hire 3 levels of employees: software engineers, IT specialists, and IT technicians. The following table gives the weekly salary level as well as the projection of the expected number of accounts each can service weekly. Additionally, Miko Consulting wants at least 50% of its staff to be either software engineers or IT specialists. Determine the number of employees Miko Consulting should hire to meet its needs and minimize total weekly costs. So the more we do these, the more complex they get. So what I would recommend doing for these is do them iteratively. So put in the basics, solve it, make sure it works. Then put in like the summation variable, then put in like the integer constraint. So let's just set this up on paper first. Okay, so what are my decision variables? What would you say my decision variables are at Miko Consulting? Yes?
Number of engineers that hire, specialists that hire, and technicians that hire.
Very good. So number of software engineers, IT specialists, and IT technicians. At Miko Consulting, what are we trying to optimize? What are we trying to optimize here? Yeah, we want to minimize our employee expense. So minimize, looks like it's 2,200 for software engineers, 1,400 here, and don't pay our techs much, 750 ITT. So you can use ABC, whatever if you felt appropriate. So if this were the end of our solution, we would hire no one, because that minimizes weekly salary to 0. But we have to support clients, and we have to support at least 75 and 25 corporate clients. So greater than or equal to 75, that's for personal accounts, and it looks like the coefficients for those are 3, 5, and 5. So 3 plus 5 plus 5, and I'd drag that down. Makes sense. That's what personal. And corporate would be 3, 1, and 0, and that's greater than or equal to 25. And they all have to be greater than or equal to. Can't hire negative people. So let's just stop there. And let's put this in Excel. Okay, let's just solve it. I know we didn't capture this yet, and I know we didn't capture the fact that these all have to be integers. But let's just stop there and put this in Excel, and then we'll add those other things. So I'm gonna rip this one off. So I'm gonna say software engineers, IT specialists, IT technicians. I'm gonna say 1, 1, and 1. And I'm minimizing 2,200, 1,400, 750. This is personal accounts. 3, 5, and 5, and it has to be greater than or equal to 75. And this is corporate, and that is 3, 1, and 0, and it has to be greater than or equal to 25. And I don't need this one, so I'm going to get rid of it. So let's just make sure things are working as we see fit. All right, so that's all I did was take what I had on paper to this, but I know I'm going to need to fix solver, so let's get the solver. My objective cell is still F4, but I'm trying to not maximize it, but do what with it? Minimize it. My changing cells are still C2 through E2. I'm just going to get rid of all these constraints and rebuild them, because it's a mess. So I'm still minimizing F4, still changing C2, E2, and I'm going to add that F6 through F7 has to be greater than or equal to H6 through H7. Click add, cancel, click solve, and all right, I just added decimal places back. It's telling me hire 8.3 software engineers, no IT specialists, and 10 IT technicians that allow me to meet my demands for personal corporate servicing. And I'll minimize my weekly salary at $25,000. Now, you'll notice it says 8.33 software engineers. So I might want to say, I'll just round that down to 8, and someone else can pick up the slack. But if I really want to capture that integer constraint, the way I do that, and this is new to you, I would go to Data Solver, and I would add a constraint that says C2 through E2. And you know the drop down where we usually put less than or equal to or greater than or equal to? There's an option there that says int. Select that. And what that's saying is C2 through E2 has to equal an integer. Click add, and I click solve, and it finds a solution. It's a much different solution, but it says 7, 4, and 7. And it's all integers. It's at 7.00, 4.00, and 7.00. And it's still 26. What was the last one? Do you guys remember what was the last salary? 20 something. You guys remember? All right. I think it was close. Wasn't it close? And I can service 76 accounts and 25 accounts, but that's the mix when I do integers. So integer is pretty easy. All you do is add a constraint that says, hey, these have to be integer. That's all I did. C2 through E2 has to be integer. Okay. Now, what I didn't cover yet, so let's go back to this. So all I'd say here, if I was writing this, I'd just say all these have to be greater than 0, and I would write and integer. Okay, that would cover that. And now I need something for this deal down here. It says Miko Consulting wants at least 50% of its staff to be either software engineers or IT specialists. Determine the number of employees Miko Consulting should hire to meet its needs and minimize total weekly costs. So I'm going to do this one algebraically. All right, I just think it'll be easier for this one. Okay, so I could do it with the summation variable. I could do it with the sum, but I'm going to do this one algebraically. So it says it wants at least 50% of its staff to be either software engineers, and I think I have that actually right now because I have 7 and 4. That's 11. So let me change this. Let's say I want them to be, 80% have to be those two. All right, let's say that. Either software engineers or IT specialists, okay? So I'm changing this because I want this answer to change. So I want SE plus ITS to be greater than or equal to 80% of the total. And what's the total? It would be SE plus ITS plus ITT. I want to distribute this. So SE plus ITS is greater than or equal to 80% of SE plus 80% of ITS plus 80% of ITT. Then I would have to subtract each of those from both sides so I get this to 0 over here. So this will become 0.2 SE plus 0.2 ITS minus 0.8 ITT is greater than or equal to 0. Algebraically, this becomes this. So let's enter that in to see if it works. So I'll just call it mix. Oops, you can see. Let's call it mix. 0.2, 0.2, negative 0.8. I want to copy that down. Greater than or equal to 0. I need to tell solver about that. So data, solver, add F8 is greater than or equal to H8. Solve. And now it says, how about this one? Do 5 and 10 respectively. To an IT technician. It's 15 of 17, which is over 80%. And also, looks like the same cost actually, 26.5. Very similar anyway. And I'm servicing 75 and 25. Now you could have done that by adding a summation variable and then predicating it off that, or you could have done it by just summing a value and doing it the third way. But any way you do it, you need to be able to actualize this, because we're going to be confronted with that situation. Okay. So here's what I'd like you to do then for homework. And we are in week 4, believe it or not. We are moving quite quickly. So the semester is moving quite quickly, actually. So next week is week 5. That's my wife's birthday, 9/20. She's not going to be pleased. I'm missing it. I just fumbled our 20th anniversary, so that's not going to be good either. So anyways, yeah, week 5, I'm sorry, you'll see I hand out the midterm take home. You see that in there? So, because I give you 2 weeks to do it. So it's not due till week 7. That's when we have our in-class midterm. But I like to give you 2 weeks to do it, just because you can do it, you can start it in week 5, between week 5 and week 6. And if you have questions on it, you can ask me about them in week 6, right? So at week 6 class, you can ask me about them. So I know there's some concern about, hey, is this due? Yes, it's due the same time as the in class, all right? But for homework for this week, I would like you to do the following. So this is chapter 3 we are in now. And this is on pages 168 and 181. I would like you to do number 3. That's a good one. It's a big one, but like I said, please, add some things and then add more things. Right? Do this in an iterative process. Add the basic constraints and then do the summation constraints. Right? So get it working and then add on, layer onto it. Do number 3. It's a long one. You don't have to do number 5. You can if you like, but it's optional. Let's see, number 11. I like number 11. Yeah, number 11 is all right. I'd like you to do number 18 for sure. That's good. Okay. And then next week, like I said, your take home, I'll pass out your take home, and I will we'll also go into binary constraints. We'll also start chapter 4, which is network models. And your first exam will be on chapters 1 through 4. So we're getting close to, wrapping up the material for the midterm. All right, well, have a great night. Drive safely, and I'll see you next week.